This is a Carboline production.
Moving sulfur by rail is the dominant mode of transportation for that commodity, and the tank cars that haul it and the linings that protect those tank cars take a real beating. The commodity itself is highly corrosive, but also the processes involved in loading it, unloading it, and cleaning up after it are very abusive. So what's the best way to protect tank cars in molten sulfur service? That's what my guests are here to discuss. And they'll share the story of a field inspection of a new lining technology which yielded some crucial findings. So we're happy to have an episode of The Red Bucket back at Carboline's Research, Development, and Innovation facility, which looks great now after some renovations. And I'm joined by Steve Liebhart and Lupe Pavon. So let's have some introductions. Steve, maybe you can go first. Who are you and what do you do here?
All right. Yeah. Thanks, Toby. So Steve Liebhart's my name. I'm currently the global product line manager for Carboline's linings, pipe coatings, and high heat coatings. So I've been with Carboline for 20 years now and trying to help market and sell our linings.
Lupe?
My name is Lupe Pavon. I'm the rail field technical manager. Been with Carboline coming up on 2 years in July. We currently supply support to all the customer shops, trainings, and technical inspection.
And the reason you're both here to talk about this is because we're covering an area of overlap between you two. We have rail cars and we have tank linings. And so when the subject of discussion is the tank lining on a rail car, that means for subject matter experts, you need both a Lupe and a Steve. I want to start, though, with a question about sulfur itself. The commodity is corrosive, but how corrosive is it?
It's quite corrosive actually, and there's a couple different mechanisms for that even, but the main thing is the elemental sulfur can react with the carbon steel and form basically iron sulfide layers, and that iron sulfide layer can actually passivate that substrate a little bit, but it can also be weakened and be part of the overall corrosion process. It's kind of a catalyst in the whole corrosion process, not to mention the fact of the molten aspect of the sulfur, the heat that's involved, and the flowing that's involved. The heat alone is quite damaging to lining. So that combined with the corrosive nature of the sulfur itself creates a pretty bad environment for a lining and for carbon steel actually.
In such an unpleasant environment, I wonder what is there a generic way to describe the normal or standard lining technology for a molten sulfur tank car?
Most folks have gravitated towards Novolac epoxies or even, phenolic type epoxies, something that has high heat resistance and overall high chemical resistance, because that is one aspect of this service that's important, not let alone the corrosion resistance aspect of the lining itself. You have to be able to withstand the physical conditions, being the heat, primarily as the breakdown mechanism, but then also the physical abuse that can happen to those coatings. So that's where those Novolac epoxies, phenolic epoxies have really kind of been the go-to products, I would say, for the last several years.
Yes, and I've seen customer specifications, shipper specification where they specify a one coat epoxy system, 7 to 9 mils, dry film thickness, and then I've seen specifications for a two coat system of the epoxy coating at the same millage, 7 to 9 mils.
How long should this last? Ideally, let's say.
What do you think? Of 3 to 5 years? That's
Yeah,
kind of what I
the
had.
inspection intervals is it starts out on a new car 3 years, and then that's the first interval inspection, and they will do whatever minor repairs, and then the next interval 2 years after that.
Yeah, that's what I was wondering. Do they often? I mean, sometimes it seems like there's repairs needed after 3 years, and then after another two, and you're at five. Is that typically where now you might need some substantial repairs?
Yep. Yes, and then when you combine that with decontamination process that it has to go through, surface preparation. You look at the hours involved. They want to prove that repair. They say, well, I can pay for a new liner.
We talk about how the steel itself of a car is impacted by this commodity. For that to happen, there has to be some sort of damage or defect in the coating first, right? So what is the more common way that that damage occurs in the first place? Is it the breakdown of the material in that service, or is it damage from all of the normal things that happen in a repair shop or out in the field?
What I typically see during inspections is the service that tank car is subjected to. The loading, the unloading, in the stress that the coating goes through. Typically, to get it that molten sulfur, it's heated to about 280 to 300 degrees Fahrenheit. So that's the stress that coating is going through is what I've seen. And then I've seen failures at the steam coil area where they'll inject 15 psi, which is converted to roughly about 250 degrees Fahrenheit to get that sulfur now to where it's at a melting point to where it'll unload.
And for that heat to transfer from those heating coils into the sulfur itself, that's oftentimes where it's the hottest and where the coating experiences or the lining experiences the hottest points there. So a lot of times you can see that discoloration at the heating coils, but it's that heating up and cycling constantly, when every time those products are heated up might create a little bit of embrittlement, and so then the combination of the heat cycling, and then the physical abuse that those cars take, this is really where you get some breakdown of the lining in terms of perhaps cracking or some other type of stress, blister, delamination, anything along the lines that way. And then once you have that pathway broken where the sulfur can get to the substrate, now the corrosion mechanism takes over pretty quickly.
I was just going to add as well, whenever cars get unloaded, then there'll be a crew that goes in there and cleans the interior, removes any hill or it's basically a commodity, and then whatever tools they use to scrape that out can also have mechanical damages to the liner as well.
Yeah. So if the lining has become somewhat brittle from the heat exposure and that constant heat and the heat cycling, now if it's getting scraped on or banged on or anything of the sort, now it can damage easier than when it was first initially installed prior to seeing those loads, and the heat that it gets. So
And that work is particularly violent with dry sulfur, right? Because sulfur itself is the word you've used when we talked about it in the past was how tenaciously it sticks to itself and to any other surface.
yeah, and that's a part about if it actually freezes and turns from a molten state to a solid state, wherever it's in contact with the car or the lining, it can tenaciously cling or adhere to the lining itself. And then the same problem can occur now, either the weight of the sulfur itself or it physically being removed during the unloading process by someone cleaning it, perhaps. If the adhesion of the sulfur to the lining is stronger than the adhesion of the lining to the substrate, okay, or it's become brittle and it is less, less flexible or what have you, it can actually delaminate from the substrate and stick to the sulfur in that process. And now you've again got pathways for the sulfur to get to the substrate and start that corrosion process.
What is happening, or what have you seen, Lupe, as the symptom or side effect of this corrosion? What happens at the surface? What does the surface look like if this sort of corrosion has gone on unchecked for too long?
Typically, what I see is the substrate starts to develop corrosion pitting, where pits can typically be very, very sharp, deep. So during the cleaning process, then you have to get a inspection done to see how much steel loss is there, and then typically there is going to be steel loss. So now you got to do build that back up, by some type of mechanical repair.
Mechanical repair gets us to where we wound our way to one of the subjects of this, which is blending, the term blending. And Steve and I had this discussion yesterday. It was a pretty short discussion because we didn't really know the answer, but Lupe, maybe you know, where does that term come to us from?
The blending comes from the NAE standard SP0178, where it typically speaks to the weld prep. The blending is what I see is how you want the coating to, you don't want any sharp edges, no sharp edges, because, the coating tends to pull away during the curing process. So you have very minimal film thickness in those sharp edges. So mechanically, you take a grinder and blend those corrosion areas, not have any bridging, where you'll have a discontinuity.
Yeah, so essentially grinding away the sharp edges of, well, what originated as maybe a weld seam, but in the case of used cars would also apply to pitted areas, degraded areas, any areas where you might have a sharp edge or transition, which is common for most linings, right? Prior to being installed, you want to get rid of all these sharp edges and stuff because of the edge retention effect that you mentioned. It's pretty common for those linings to want to pull away from the sharp edges unless they're built accordingly to maintain that edge retention on that sharp edge.
Correct. So when the previous lining is removed, now it goes into the mechanical process where they'll inspect the thickness of the shell, of the tank shell, and then they'll start grinding and blending of those areas that need to be built back up by the welding process. But that's a lot of square footage. You're talking about 1,000 to 1,100 square feet of steel, right? There are some areas that might be missed, and it might be more of a omega pitting, what I call. So those are very challenging for a coating.
What does the process look like of actually doing the blending? It's a person with a tool, right? But take it from there. What are they doing?
So yes, they have a, pneumatic tool, and they're actually hitting the substrate, and they're blending those areas out to where you want to eliminate that the sharp edge on that pit. So that can take hours. Every car is different on how it corrodes because of the exposure, right, of how the previous liner deteriorates. So I mean, you're talking about a lot of man hours to do that process. Taking that disc, that sander disc, which is 40-60 grit paper, and then you're grinding those areas.
I mean, and it's a physical job. I mean, you're removing metal. I mean, sparks are flying. It's a
Yeah,
because your goal is to make the surface more uniform in nature. Okay, you don't have steep or even deep transitions where these are difficult for aligning because when you take a sharp edge or a deep transition, you're asking the lining to flow into those cavities and fill those pits nicely. Okay, flow and wet out into those pits, but then also maintain some level of thickness on those sharp edges. You've got edge retention and you've got flow and leveling properties. And when you're talking about aligning, these are generally two opposing features. You don't typically have both, where you either have good flow and leveling characteristics or you have good edge retention. But oftentimes you don't have both because those two features oppose one another. And in order to flow well, you typically don't have good build and edge retention properties. So this is why it's important to get that coating applied uniformly by uniforming out the substrate by doing that blending.
So we should probably introduce a product now. And I am always a little bit skittish about mentioning products on the podcast because we're not trying to sell per se. But we do have one that has an interesting set of properties. Since Steve, you said opposing features a few minutes ago. So talk about Plasite XHT 400 and these, opposing features that you said that some maybe generic products have. This one sort of bucks that trend.
Yeah, that would be fair to say. I mean, because the XHT 400 it's a new technology, modified epoxy that quite frankly has a lot of the features that are really important for good performance in the molten sulfur service. And so, talking about those two features with regards to edge retention and flow and wetting characteristics, this product does actually seem to have both. It flows really nicely into the pits and into areas that need good wetting, as opposed to bridging over the top of those and leaving some sort of gap underneath. But yet it also holds the film thickness nicely on the sharp edge, so you get adequate coverage on that edge, but then you also adequately flow into those irregular areas and pits. So it's kind of unique in that regard. Um, but those are just some side features of the product. I mean, obviously having the high temperature resistance, the extremely good impact resistance, adhesion, all of the other features, the abrasion resistance, everything that goes into the um, reasons how and why these linings can fail in this service, from the heat or from the abuse. This product has the features that pretty much overcome a lot of those issues.
I think we flirted with this a little bit earlier about incomplete blending or improper blending, or you said that's a big square footage. Sometimes you make a mistake, it might just get missed. So there's potential that this kind of covers you for that. Is that fair?
It's fair to speak to that. So when a tank car is clean to spec, white metal blast, or applicator is making sure that those no areas that are miss the cleanliness level of a white metal blast. But then he's also noting areas that will need a stripe coat. So you take the coating, dilute it 50%, and you want to hit those areas that are rough to make sure there's no bridging during the actual full coat application. But with this XHT 400 or coatings engineers that are out there working with the shops, they're really impressed on there's no need for the stripe coat.
And that stripe coat that you speak of, I mean, this is also commonly used on welds, irregular, areas, geometries, this sort of thing, because you're physically wetting out that material on that weld or that at that area, because again, a lot of products, don't have the flow and wetting characteristics to do that all on their own. So you physically do it with the brush prior to putting your primary lining over the top, and that ensures that you had good wetting out and adequate coverage of that weld seam, basically.
Of course, every car is going to be different, and the amount of added work that you can avoid doing by using this product will be different case by case. Is this a pretty significant time if you run that over, a file of cars? What kind of savings are we talking about here?
You're eliminating an extra step in the process. You're looking at 30, 45 minutes to an hour to do those areas that are heavily corroded. So that's one part of it. The other is the consumption, having to mix measure kits just for that particular process.
There was an inspection that we performed last summer. So there were two tank cars that we got a hold of. They were about 20 years old apiece, and they were prepared and then lined in the XHT 400 in the very late part of 2021 and the early part of 2022. They were about a month apart, straddling the new year. And then we came back 2.5 years or so later to look at the performance of that XHT 400.
Correct.
It was observed that some areas of that substrate should have been blended. They weren't, but they could have used it.
They could have used it. They could have used it. And upon inspection, we were amazed at what we were seeing. I mean, there was no deterioration of the coating in those sharp edges. There was no cracking that you would see and experience in those knuckle areas from transportation and the service that it goes into. Yeah, we were really impressed.
At some time when we were gonna line those cars, I don't know if anybody commented like, "Hey, these cars are in pretty bad shape," or if we were just happy to get those cars and line them and put them in service, and get some track record under us because going from lab testing to real world exposure is not always a direct, one-to-one correlation. So it was important to take the good performance we were seeing in the lab and actually get that lining into some real world service exposure and line some cars and get some service under our belt to actually um, have that track record.
Correct, correct. And we were just happy to get those cars. They went through the decontamination process and then pre-blast inspection, where you inspect, make sure everything is clean, and then you verify the non-visible salts and make sure your pH is at a neutral. Our coatings engineer was out at the shop. He was like, "Wow, this car's pretty rough." And so we had a quick toolbox meeting with the cleaning crew, and we mentioned how not to damage the liner, right? So tools or what they use is very important. So the cleaning team had the plastic scrapers and shovels, and then they said, okay, we're going to go in there, pressure wash and see what it does. And then we'll use these scrapers and shovels. So they pressurized the pressure washer at 3000 PSI, and they went in there, and one of the operators came back out and said, hey, let me see your phone because I want to take some pictures and videos of how well, yeah, the commodity is cleaning.
Because this is also an aspect of the abuse that the lining takes, because when it doesn't come off easily or doesn't clean easily, it requires more and more effort to get that stuff off of there. And as you can imagine, the more and more effort typically comes in the form of brute force, which is either banging or scraping. So the lining does not usually like that.
So there's this potential for time savings by being able to skip certain steps on the front side, and then you observe this property or this potential that cleaning is a lot easier, less time intensive, less involved. So savings on maybe both ends of the transaction, if you will.
Yeah, and I would say that, the big savings likely comes in terms of extended service life of the lining. Okay, if you can get twice the service life of the typical linings that are used today, that's a huge win. All of the other things that we've been talking about, okay, skipping a few steps here, saving on some manpower there, those are all peripheral benefits that could be saved on each and every car in the file. But I think a lot of the money comes from the extended service life of the lining that you get from making all these other things easier and experiencing less damage of the lining in those cars as a result of that. And by the way, it should be mentioned that these cars saw the normal amount of molten sulfur loads that any other car would see, during that process. Okay, if you've got 2.5 years of service with pretty much perfect performance on really ugly substrate, okay, that wasn't blended and had some really, really rough texture in there, versus 2 or 3 years of service with the normal going product that might come in for inspection and require, anywhere from small amounts of repairs to significant amounts of repairs. It seems to me like that case study alone, might help make that decision right there and anticipate much better service life out of that lining in a new car. I think the question that they all probably want to know is same thing like we want to know is how long is it going to last.
Correct.
And right now, um, that story's playing out as we speak. I mean, the clock's ticking right now. It's still in service. I mean, from what I had seen inside those cars when Lupe and I were inside inspecting those cars, there was no signs of degradation or deterioration whatsoever that I could tell. I mean, even after cleaning, the lining was still glossy. It had like, you know, no impact hardly whatsoever from the service that I could tell. So my thought and anticipation is, okay, it should probably go another 2.5 years, without any issue. And this is what I'm anticipating. I mean, this is theory of mine at the moment, but this is what I'm anticipating based on what I've seen, and I've tested and evaluated a lot of coatings, in my time. So just theorizing that we're looking at, probably twice the service life than what we've seen so far on linings.
Well, the potential for twice the service life is nothing to sneeze at, and you mentioned those cars are still in service. So let's create a bit of a cliffhanger here, because after Steve and Lupe inspected those cars last summer, they went back out on the rails. I hope we get the chance to take another look inside them in about 2 years' time. And if we do, I'd love to have these guys come back and talk about it. But now, Lupe and Steve, I have 4 very important questions for each of you to answer, so I hope you're ready. On a scale of 1 to 10, 1 being the worst and 10 being the best, how would you grade how well you drove in the snow this winter? How much snow did you drive in this winter, Lupe?
Some up in Canada. So I would say a 7.
I would say probably a 9 or a 10. I like driving in the snow. I mean, I feel like most people don't drive so well in the snow, and they're usually like in my way and aggravating me. So I feel like I'm a 9 or a 10 snow driver.
That's why I gave myself a 7 because I'm super cautious and I know they're probably saying, "Hey, get out of my way."
I'm the guy behind you that's aggravated. Say, get out of my way.
I kind of feel like Lupe's the 9 or a 10, and Steve might be the 7.
Self-proclaimed 9 or 10. I don't know how the other drivers think of my driving.
So that's spoken like a St. Louis driver, because everybody here thinks they're great. Everybody here is actually really terrible.
I agree with that. I'm just not one of them.
St. Louis style pizza, gentlemen. Steve, you're in St. Louis, have lived here.
Love it. Been
Love
born and raised on it, and yeah, I mean it's kind of unique to the St. Louis area, actually.
Have you had it?
I have not. I have not had the opportunity. So Steve, is it like Chicago style? That
No, it's very thin crust,
ah,
like crispy, crackery crust, but St. Louis has this weird cheese. It's called Provel cheese,
oh,
and it's kind of unique to the St. Louis area. Actually, it's a blend of cheeses, kind of whatever. But that's what goes on the St. Louis style pizza and these thin, crispy cracker crust. And I think it's really good.
wow.
It's a unique flavor that's different than most.
I asked a winter question earlier, but we're on the tail end of it. It's the first part of March now when we're recording, and that means gardening season. If there was a vegetable that you grew and would never get tired of eating it, what might that be?
So I do happen to actually have a pretty decent sized garden. I do a lot of gardening here, and every year I kind of anticipate or waiting patiently for homegrown tomatoes because homegrown tomatoes taste a lot better than tomatoes that you buy in the grocery store. But at the same time, as far as vegetables that I would never get sick of eating and would love to be able to grow better would be zucchini because I like zucchini, but I try to garden without pesticides, and my zucchini just doesn't do very well without pesticides.
Hit the squash borer.
Oh yeah.
I love okra. So okra would be one.
Those of us in St. Louis who became Chiefs fans after the Rams left town, at this point in the month of March, are about a month away from watching an absolute beatdown in the Super Bowl. So maybe that wound is not smarting as much as it was a month ago. Do the Eagles repeat next year?
Sometimes teams win the Super Bowl and then they dissolve the team and a lot of key players leave or go elsewhere. So, but I do like the Eagles and I would love to see them, repeat if they could.
I say they could give it another run. They're going to make it a really good showing.
Okay, we'll leave it right there. Lupe, Steve, thanks for a great conversation.
I appreciate it. Thank you.